Okay, welcome back. On the heels of the K4900 in the previous video to this one, this will be chassis number 2 for the same individual. They sent the K4900 and the 7000 here, and if you go back and watch the video before this one, you'll see I had 2 in the same wrapping and everything. So this is chassis number 2 for the same person. It's a K7000, and from what I'm told, it's dead. But we can verify that here, which I'm sure there'll be a note in this one like there was with the last one. If I recall correctly, it's been a few days. Yes, alright. There we go. So let's get this out of here. Alright. It's a 25-inch. Well, fuse is missing. Indication number 1, and the tie down for our B+ wires and our AC wires is missing. We can zip tie that back down. Not a problem. It looks like somebody has already capped it and replaced the flyback, so we won't have to worry about that. Some loose glue here, but that's not a big deal. How do our pots look? Pots appear to be okay. Someone even changed the filter cap. Never seen one that looks like that before. That's short. Huh. But before we turn it over and examine the back side, let's read the note. This someone's replaced D18 and R97 was smashed over. Okay, neck board. Color transistors are secure. Color pots don't appear to be broken. We'll preemptively put them all to the center position for when it comes time to test. We'll have to reflow some of this, but nothing too bad. Not sure why that resistor's there. I don't think that's normal, but I could be wrong. Our ground wire is kind of haphazardly soldered on here. And before it breaks off completely, let's fix it so that won't happen. Can I fit that through there? I should be able to. Yes, okay. And let's see if we can secure these with a strain relief. Alright, that helps out pretty good there. Okay. So I just put a zip tie here to act as a strain relief. So now when these bend back and forth, they don't bend back and forth at the solder point, they bend back and forth at the zip tie point. So it's a bit of insurance so you don't break your wires off. So that is secure. Alright, the other remote board here. Now this is one of the rarer ones that has this type of remote board. There's basically, you can see here that vertical position and horizontal position are removed from the chassis, and they are here. But there's a redundant vertical size and black level. Black level and vertical size, there's 2 on here, and there's 2 on here. So it's a redundant setup for those 2. I'm not quite sure why they engineered it that way, but that's just the way it is. Now, on I'm going to have to reflow this, so I'll cut this off here, but almost every one of these types of remote boards that I have ever seen in all of my journeys through these chassis, the solder joints on the back side of here for this header connection are almost always broken and cracked. This one appears to be somewhat okay, but it's teetering on the brim of cracking up. If you look here, this one here, Looks like it's on the brink. I'm looking through the viewfinder here, so we got this one here and this one here. So almost all these are always either broken, cracked, or on the brink of cracking or breaking. And it's very common to see people plug this in backwards. If you plug this in backwards, you won't have any vertical position or horizontal position. You'll have it. It won't be collapsed, but it'll be all wonky, and you'll have deflection problems. So you always want to plug it in with the wires facing this way, not that way. So that being said, we're going to disconnect this and set it aside for the moment, so it's not in our way, because we don't need it for testing. All right, let's read our note. Then we'll take a look at the bottom side of this thing. Let's make sure there's no important data on here that I shouldn't show on camera first. There wasn't on the last one. Okay, here we go. Let's zoom in here. All right, capped, checked all diodes, replaced flyback, HOT, pads were pretty much gone, but I did my best to get connections. And the voltage regulator, it was getting around 129 volts at B+. It got net glow for about a minute before it melting down, and I'm assuming annihilating some, if not of all the components I just replaced. All right, so obviously there must be something wrong with some other component that either got overlooked or is not normally tested or checked. We'll see what we can figure out. Let's look at the back side here and make sure there's no... Oh, well, I already see the problem, if not a problem. Our, let's see here. Hang on one second, my phone's ringing. All right, sorry about that. All right, so R101 is one thing you always want to look at, and sure enough, I don't even think that it's soldered in. If I pull on this here, I bet you it come right out. Well, no, not really, I guess, but that pad is pretty much, I don't even see any solder on it, almost none. So I'll bet you that is the problem, if not one of the problems. So we'll have to go over that. And let's zoom out here and take a look at some other stuff. All right. Let's just look things over here. Looks like the mod here has been done to the critical safety cap to replace the 4-post with the 2-post. So we're going to have to make sure that that is correct. Now, you install these two jumpers here, this jumper and this jumper, and then you attach the 2-post onto those legs. So you can actually use this leg or this leg or this leg or this leg, doesn't matter, as long as you attach the cap across these 2 points with the jumpers installed, it'll essentially act like the original 4-post C36. So the C36 has been replaced. It looks like the mod has been done correctly. So we'll test it. We got a giant solder ball in here on the on the HOT. So that's not right. And I'm sure that our most of our problem lies in the fact that we've got R101 all messed up there on that solder pad. But we can go through and test. I mean, if it worked for a few minutes and then burned up, I don't think it's a capacitor problem or a solder joint problem. Oh my Lord. I say that, but then look at the flyback here. We've got some serious issues here going on with the solder work on the flyback. Well, rework is always fun. This is not necessarily the problem or a problem, but it does need to be reworked. It looked like it had some decent connections there. And here's something else. Look at that. Found it. R89, this resistor here, look at this. You look at the solder joint here, right there. So that's not even soldered in circuit. So that's problem number 2. Problem number 1, problem number 2, And all this stuff here is problem number 3. Problem number 3, easy for me to say. Our filter cap is barely even soldered in. If we look here, there's our leg. It's barely even soldered in, so that has to be fixed. It looks like there's some damage here on the traces from a burn or scorch mark that's been jumpered, so we'll have to take a look, make sure that's okay. Our HOT rework, yeah, there's kind of butchered here. My phone's ringing again. Hang on one moment, I'm busy today. Alright, sorry about that. That's the second time that's happened. Okay, so let's, I think with the fact that, I keep putting these away, the fact that, I want to get this right, it worked for about a minute and then melted down. Because of that, I have to assume that this critical safety cap C36 mod's okay, the HOT was okay, voltage regulator was okay. I think our problem lies in this very bad R101 solder joint and R89, this broken R89 joint that we can move in and out there. So I think our problem lies in just some bad solder joints. So let's go through and test everything. And if everything tests okay, we can just resolder those pads, fix these pads here, go through and double check anything else and reflow anything else that needs it, and I'll bet you it'll operate. But I want to do the testing here first. Okay. So we'll start with the voltage regulator. We should read, I think 0.160 across 1 and 4. Nope. The voltage regulator is shorted. How about our HOT? Shorted. Oh my lord. Critical safety cap's probably going to read shorted as well. Yeah, because the HOT is bad. D18, did that survive? D18 is shorted. What about C38? Well, C38's not shorted. Oh my lord. Let's start taking all these components out one by one and then keep testing here. Oh, I hate when they use these. They don't, instead of having screws in here, they have these hex bolts or hex screws. Don't suppose these are a quarter. Hey, they are a quarter. Okay. All right, set the hardware out of the way. Man, let's get the desoldering gun up and going. And let's take the HOT loose here. Okay, that's out of there. I think they might have a counterfeit voltage regulator in here as well, because that looks very suspicious. Or as the kids nowadays say, that looks hella sus. But that might be the first time that might be the first time that I have ever uttered that phrase in my life, and I immediately regret it. So HOT, voltage regulator, D18. Let's just start by removing all of those and then verifying that our C36 safety cap is no longer shorted. D18, yeah, I want to check it from the top side, and it had been replaced previously because it's definitely not the right one, and it is shorted. So I gotta wonder with D18 doesn't normally short unless you've got something wrong with your yoke. However, with the R101 and R89 being pretty much basically out of circuit by the bad solder joints, that could have been a casualty. So we'll change that as well with the correct one from a donor chassis. And it looks like someone's replaced all of the Looks like someone's replaced all the rectifier diodes as well. But those all test okay, so it's not an isolation transformer issue. Okay, now that we have the desoldering station up and going, let's remove these components. Okay. Let me get my fan running here. Now you don't have to use a soldering iron, it just makes it easier because there's more surface area to heat up. Makes it easier to remove, especially on these large ground planes like this. There's hardly any solder on there to begin with anyway. Alright, HOT. I don't even think that this jumper I was soldering, I didn't get that in frame there, sorry. This thing just popped right off. As soon as I heated up this pad to use the gun, this whole thing just popped right off. I don't even think it was soldered to the pad. So that might have been another problem, problem number 4, I guess. Lost count. I think that this was all... The fact that this even powered up and worked for a moment or so is pretty amazing. I gotta get D18 out of here as well. That's right here. Okay, get rid of this. Alright. So HOT. And let's remove the insulator so we don't lose it. And there's a nice big glob of greasy, grimy solder guts on there. So we'll set that aside to test it out of circuit. Voltage regulator. Get that out of here. Set this aside. This looks very suspicious and rebranding here, rescreening. That does not look. I could be wrong, but we'll compare this to a new known good one, and we can remove this insulator. Alright, D18, let's get this out of here. Alright, so let's begin testing here. D18. Not shorted. So do the pads read shorted? Nope. Okay, so it must have been the HOT that was causing D18 to read shorted in circuit. So out of circuit, it's good. So that can go back in. Critical safety cap is not shorted, so that's okay. Our voltage regulator pads, we should be back to was it 200 ohms or so? 180? So pins 1 and 4 should correspond to the B+ resistor. So there we go. It's a bit low, 170, but it'll climb up. So okay, now let's see about these pins 1 and 4 shorted. Voltage regulator, most likely counterfeit one, bad. HOT shorted. Alright, well, let's continue to go along here and see if there's anything else that might be bad. We tested our rectifier diodes. R203 here should read about 3 ohms. 2.8, so that's good. R101 should be 1.8K. I'm sorry, no. It should be about 6K, but about 4.5 to 5 in circuit. Okay, 6K. That's going awful high there. Okay, that's kind of out of tolerance, but with these other components removed, normally it's about 4.5 to 5K in circuit, but with the voltage regulator and HOT out, it reads a bit higher. So I'm not going to worry about changing this out yet. It looks okay visibly, and it reads 6K or so, kind of high, but I think I want to wait and retest it after we get the new components installed. I bet it'll be about 4.5 to 5. So we'll call that okay for now. 270, this one should be 270 ohms, yep. R96 should be 1.8, and R88 should be 1.8, yeah, and R89 should be 3.9K, yep, and then R104 should be 15 ohms, yep. So all the power resistors check okay. C38 checked okay. C36 checks okay. Rectifier diodes R103. D18, we can put it back in circuit. As a matter of fact, I'll probably just put it back in circuit now. So then we'll have to grab a new HOT, new voltage regulator, put those in here, clean up all the solder joints, all the rework, get that complete, and then we'll test it. So this is going to be fun trying to put this in here, especially when you put it in the wrong direction. Okay, so that's back in now. We'll solder it back in. And I'm going to put my bridge here that I normally do. There we go. And in circuit, it reads good. All right. So it must have been the HOT being shorted that caused that to read shorted. We also need to check D13 and D14. I believe this D14 goes this way, and that's a normal reading. D13 is the opposite way, and that's a good reading. Let's make sure we're not going to have collapse, so we'll check R91. 1.2 is what it's supposed to be, and then R92 is also 1.3, so those two resistors should be 1.2 ohms, and they're close enough, 1.4, 1.3. So unless we have a bad vertical IC, we shouldn't be greeted with any vertical collapse issues. So let's get these components replaced and then do our full reflow work and a bit more inspection. And assuming we don't find anything else, we'll power it up. But I want to do some show and tell here, because I am almost positive that this is a counterfeit voltage regulator. Although it wouldn't have powered up at all if that was the case, but I'm still hesitant. So I've got some counterfeit ones here. Right there. We can use, let's see, that's a 30. Okay, 3130. Got a couple of those. These are 23s. These are all 23s. So we'll put that back in. I guess the 23, yeah, see, maybe not. Let's grab 3130 and a new 1398. Alright, and let's get all of this out of here. Oh, we're going to need a new fuse here too. But we'll use our circuit breaker first. So I think that this is all going to come down to bad rework. This likely could have been just fine after the rebuild, but I think this is all going to come down to faulty rework that killed this stuff, but we'll find out here shortly. Alright, so we'll set our new fuse aside for later. HOT we know is bad. Voltage regulator we know is bad, but I don't know. See, if we look at the silk screen here, I realize it's different, but see, this is a counterfeit one, and you can see how the silk screen is different font, it's larger, and it's kind of coming off here in various places. It shouldn't be that way. If we grab an actual 3130, that looks pretty close, I guess. Maybe it's not. I was, just from a quick glance, I thought it was a counterfeit one, but after realizing it's a 3130, not a 3123, this is for the 19-inch, I take that back. It may not have been a counterfeit one, and that makes sense because it did work. It powered up and operated for, you know, at least a little bit. If that was counterfeit, it wouldn't have happened. It would have died immediately or done something else. So, but I can show you what a counterfeit one reads. If we test a good one here, here's our good one. It's pins 1 and 4 is what your diode is supposed to read here. Let's get that where you can see it. Okay, on the good one, we go to pins 1 and 4. There's our diode. If we go to the counterfeit one, pins 1 and 4, we don't get our diode. If we go to 1 and 2, there's a diode. I think it's 2 and 4. 2 and 3. One of these has the diode where it shouldn't be. I forget, but basically the bottom line is on a correct operating voltage regulator, it's pins 1 and 4. You can clearly see that I've got my pins 1 and 4 are the two wires, are the 2 points that feed your B+ resistor. If we look at the chassis itself, you can see that the red wire goes to pin 1 and the blue wire goes to pin 4. So you need to have your diode across pins 1 and 4. And as you can see on the fake one, we don't get our diode. There's no voltage drop. Well, it's 0.9 voltage drop, but it's not a diode. So that's what, if you get a batch of voltage regulators, you always want to make sure that they read the 0.5 voltage drop across pins 1 and 4. That's a good reading. This one here is not. So just a bit of information there. See, I have another one here. Let's test this one. You can see that I was able to use alcohol and remove the most of the silk screen there. If we go to pins 1 and 4 on this one, any guess what's going to happen? Negative on pin 1. There you go, another one. Missing the diode on 1 and 4. It's only on 1 and 2. And the good one has it on 1 and 2 as well, but That's not the important one. The important one is 1 and 4. That's 1 and 2 and 1 and 4. So here's a couple examples of some counterfeit ones. And I keep those around just for example. Alright, so this is our bad one. Let's verify. We don't put the bad one back in. 1 and 4. Shorted, yep, okay. And let's test our new HOT. Negative on the center, and then to each leg should be 0.5 voltage drop. Actually, I think it's only this leg. This leg's 0.5. Other leg I think is actually open. Oh no, okay. Depends on which. I've do so many of these I forget, but center leg and then 0.5 voltage drop to pretty much each leg. There you go, close enough. So it's not shorted. Alright, so let's put these in. Fix all of our solder. Make sure nothing else is bad or wrong. And test this puppy out. Because all we found so far that was bad is the HOT and the voltage regulator, and most likely due to all that bad solder joints and bad solder rework. And of course you want to bend your leg so it looks like that when you go to put it back in. And it should drop right in. There you go. Let's get put our screw through here. And I'm on the wrong screw hole, you rat bastard. There we go. Okay. And again, you don't want to tighten the ever-loving piss out of this. You just want to get it nice and snug. As soon as the screw stops moving, that's all you need. You don't need to torque it down, tighten it. As long as it stops moving, as soon as it stops moving, that's all you need. Because people will over-tighten these, and they'll puncture the insulator and short out to the frame, and that's going to give you a bad time. So you don't want to do that. Are there 2 insulators on this? Sure enough, someone's got 2 insulators. I took this one off, and there's another one already here. Huh. Well, just for good measure, I've already got it. Let's put it back on. It won't hurt anything to have it on there. Okay. Did I mix these damn things up again? I think I did. Okay. Well, this is always fun, trying to get this to line up. He says, as it easily goes in. Well, that was way too easy than it normally is. Alright, so we'll get these back in circuit here. Alright. So let's check to make sure that, oh, you know what, might as well do the HOT at the same time here, since we have to test them both. And there we go. Bend that over to there. And let's remove this. Bend that over. Okay. And bend that over to this. There we go. Okay. Sometimes you have to finesse it a bit. Well, that one was easy. Okay. Is that gone? Okay. Oh, sorry, moved it out of the way. But there you go. Not beautiful, not award-winning, but it should work. And let's go ahead and hit this one that was broken completely. There we go, beautiful. Now, we're gonna have to fix this R101 here. What is that? I guess that's just the angle. Okay, let's... Yeah, this had some solder on it that was keeping me from taking it out, but I don't think it was even testing for continuity. There's no way, because there's nothing left here. There's nothing left here with this. Yeah, it's gone. I wonder if we should be able to... I don't even think that that's going to go back in without some cleanup here. And this side is all oxidized as well. If we look at the opposite side, this is why I always just bridge these. I always just normally bridge these two pads because of this. Look how oxidized this one is as well. So I don't even know if it was making a connection on this because of the heat. The heat from this resistor oxidizes this pad and this pad very severely. But look how that should be copper and it's black. There's no solder on it. It's just gone. So that's why I always bridge these 2 points, because that even if this over time gets oxidized again, it's still connected and you don't got to deal with it. Plus it helps with heat dissipation by having it actually physically solder jointed over to that one. So now we need to fix that one as well. So you look at it now. Just from cleaning off the oxidation, there you go again. So R101 is the main culprit for a lot of power problems on the 7000. So now we've got it back in, and of course it pops the pad off. There we go. Okay. Let's solder it back in place, and here's what I normally do with this, is we'll add the solder to it. So that, normally that, gosh dang it, normally that right there would be enough to be okay, but we're going to reinforce this by doing that. There you go. That's not touching there, so don't worry about that. That is what I would consider not a proper repair, but a more secure, time-tested repair. And the same thing over here. Look how much better that pad looks just from the using this sanding pin here. They call it. It's a there's no part. It's a sanding pin, and I'll link it below. So there you go. Even that would be enough to call it a decent repair. Well, hang on. Okay, so not perfect, but that'd be enough to call a decent repair on its own. But I always just bridge this over to here, like that. Then you never have to worry about that happening again. So, all right, now let's fix our flyback solder. This is, man, I haven't seen one this bad in a while. Alright, so now that that's all done, let's test our components in circuit again. And we'll start with the HOT. 0.5 and 0.5. Critical safety cap is good. That reads through the HOT. D18 no longer reads shorted in circuit, so that's good. Voltage regulator should be about 0.160 voltage drop through the B plus resistor. 1.15, close enough. C38 width cap. Sorry, these two. Threw me for a loop there. I'm like, how could it go bad already? Or all by itself? These two here, open, okay. I think this goes across the linearity coil, if I'm not mistaken, yeah. Okay. Now let's check R101. Again, it should be 4.5-ish. I bet you it's around 4.5 again after fixing these components. No? 5.5? Yeah, not bad. I'm going to call it okay. Pardon me. Alright, so now all of our components are resoldered in. We fixed our critical problems. Everything tests good. So let's give this a good reflow, and then we'll hook it up and test it. I need to fix the solder on that filter cap, but I also want to secure these wires here the way that they're supposed to be. And I think all of our problems came down to those bad solder joints on R89 and R101, this one here and that one there. and probably bad solder on flyback or this filter cap. I mean, it could be any number of different things. I'm not sure why. Now wait a minute. Is because it's too wide for the... So negative, okay, they've got it hooked up correctly. Negative is the stripe, and that corresponds to this one, which as you can see is definitely our negative. Then our positive is this one. So they've got it properly in there. And like I say, this would not have worked at all if any of this other stuff was actually bad. But given the bad work on everything else, there we go. None of this is necessary. I just like to... There we go. Okay. So let's go through and resolder anything and everything that might appear to even remotely need it. So we'll hit C38 here. Width cap looks so... I'm sorry, width coil looks okay. This repair here on the traces for the ground, that seems okay. Degauss coil header pins, we'll hit those up. R104. This one, either of R104's pads always like to crack, so we check R104. Someone's had R103 out before because they've broken off one of the anchor pads. And I like to hit this ribbon cable. I've seen these ribbon cable points get broken a lot. This ribbon cable right here that goes from this point to that point, I like to hit. It's these three pads here, and then these three pads up here. I like to hit those. Video header pins are always a good idea. Sorry, you gotta sit here in silence. But I'm not a technical marvel when it comes to editing, so alright, I think that might just do it. give it one more perusal. The shutdown pot solder looks kind of haggard, so we'll hit those. I think that'll do it. Let's test some continuity here first, though, just out of curiosity. Alright, so that's okay. Alright, I think we're good to go on the main chassis. Let's plug this back in, and like I say, wires go towards the back like this, and let's toss a couple of zip ties back on it. Okay, and there was a couple of points here for the socket that I wanted to hit that looked pretty thin. So we'll hit all these. Everything else seemed okay. And it looks okay visually. Focus wire. Let's verify it's soldered on okay. Where did... Am I blind? I'm blind. Yeah, not bad. Okay. Well, I think we've done our due diligence. Voltage regulator HOT seem to be the only casualties, so let's get tube. Let's get this hooked up on the tube, and let's put our circuit breaker installed on here and turn it on, see what we get. So real quick here, let's do a quick ATAF, or all tools accounted for if you're a layman. Alright, so when I hook up this circuit breaker, I take it across this way and across this way, and yeah, and then that way if there's something that's still shorted, the breaker should pop and save us a fuse. So we'll get this hooked up and we'll turn it on, see what happens. Okay, all hooked up. We got anode, neck, yoke, ground, power, and remote board, but we do not have video because I want to make sure that there's nothing that blows up on here and sends a feedback and destroys my test pattern generator. So if it does turn on and operate and doesn't blow our circuit breaker, then we'll turn it back off, hook up our video, and see what we get. But the breaker is right here and it's hooked up. So Nothing to it but to do it. Let's turn it on and see if it even turns on. If it does, how long it lasts. If it lasts more than a few seconds or so, then we'll go ahead and hook up a video signal and see what we get. So here we go. 1, 2, 3. It's working. That was a bit more energetic static noise than normal. We currently have no image, but it's likely because we don't have a video signal. It appears to be running. And so far, so good. Oops, sorry. Okay, I'll bet you the flyback is turned all the way down because it's been replaced. Let's verify that. And nope, they had it up pretty much all the way turned up. Let's turn it all the way down and then up slightly. Okay, all the way up. I don't have an image yet, but let's turn it back down to about there, all the way down, and then we'll turn it up just slightly. Okay, what about our black level? I just want to see if we get raster lines. Black level does nothing. Well, I'm not confident so far. Let's go ahead and just hook up a video signal. I should get raster lines without a video signal. There we go, and turn this on. What's going to happen? 1, 2, 3. Yeah, it's super tall. Vertical size does nothing on the remote board. I have to get an adjustment tool here. We do have an image, but yeah, something's very wrong here. Let's see if we can adjust our vertical size here. There we go, got it. Someone had it maxed out. Okay, now does this one work on here now? Yes, it does, but not very much. Like I say, it's supplemental. The only ones that are really required here are horizontal and vertical position. But we have an image, but it looks like garbage. So let's start with, let's see, brightness. Okay, brightness control on the remote board does work. I'm turning that one, and it does operate. So we'll turn that all the way down, and then we'll turn our contrast, all the way down, brightness, all the way down, and now let's see if we can get raster lines on with the flyback turned all the way up. No, we don't. So we're not going to worry too much about that. So we'll put the flyback back to about, I don't know, a quarter of its travel. We'll put this one to about half of its travel, right about there. We'll leave it there, and then we'll adjust supplementary with this brightness, which we get nothing, all the way up, and contrast. There we go. Wow, okay. So if we turn contrast down to the point where it doesn't bleed, that's as bright. That's brightness maxed out on the chassis and halfway on the remote board. If we go full blast, yeah, it bleeds. So that right there is the limit for brightness and contrast without it bleeding. We still have something ultimately wrong with this. It is operational now, but I need to go through and verify the caps are the right. Oh well, see, somebody put polarized caps in the location where you're supposed to have bipolar caps. These three caps right here are supposed to be bipolar, and they're for your color, and they're not. Someone's got polarized caps, and here you see the negative, the blue stripe on this side. That's a polarized cap, so I need to change those out to bipolar caps. and see if that helps, because I think that may be our cause now that I look at it. Because I cannot turn, I don't get raster lines when I turn up the flyback. That's issue number one. Issue number two is I can't turn the black level or the contrast up any higher than it is, or it starts bleeding, and this is all I get. So I'm going to change those caps out to bipolar caps. You hear all this static. I'm not getting shocked. It's just static electricity from energization. So I'm going to change these out to bipolar caps. Then we'll see if that fixes this color issue. So stand by one moment. Alright, so I have the new bipolar caps installed. The original ones that were in there that were polarized are right there. I have a new fuse installed, since we know the chassis works, as you can see right there. So let's see if putting those bipolar caps in there fixed our issue of the color problem. So let's turn on our test pattern generator, and here we go. 1, 2, 3. It does not appear to have made a damn bit of difference. Let's adjust focus here. Ooh, that was odd. So there's focus. Wow, okay. There's the flyback turned all the way up. Oh, you know what? Oh, I thought maybe they had the G2 wire and the focus wire backwards, but no, that's correct. The thick wire is always the focus wire, and the skinnier wire is always a G2. So that's correct. Turning that up when it flickered there, I thought that was because they had it on backwards, but no. Okay, now we have good focus, but we've got no blue. Maybe that's our problem. If I turn up contrast, do we get blue? Where are you at there? There we go. Do we get blue? We do, but you can't see it. I gotta max it out to see it, and then it bleeds. So roughly there. Is it because blue is turned? No, blue's halfway up. Okay, if I crank up the drive, it reads. Something is still not right. All the color pots are centered, and I should be able to turn the flyback all the way up and get raster lines, and I'm not getting raster lines. Something is still not correct here. So I'm going to have to go through. We've got all of our colors, but blue has to be maximized. I wonder if there's an issue with the neck board, especially since we had that brief clicking or sputtering or whatever you want to call it when I tried to adjust the focus. I wonder if there's something going on with the neck board. I'm tempted to swap this out with another one just to see what happens. I'm going to do that and report back. If it makes no difference, I'll keep going. I'm going to get this solved, and when I figure out what the actual problem was, obviously I'll edit right back in and I'll talk about what that was, and hopefully that'll wrap this up. So give me a moment and we'll see what I can figure out. Well, my suspicions were correct. It absolutely is a neck board problem. This is the neck board off of the chassis that we're working on that has the problem. This is one off of a working 7000. It's a 19-inch 7000, but it's the same neck board. You can see these are the same neck board. This is a working one. This is our suspect bad one. Well, I know it's bad, I should say. And then here's another version of the same thing, just a different style. You can see it's brown versus green, but otherwise it's the same neck board, but it has a different socket and a different design here. Well, I guess it's the same design, but different color board and everything, but different neck board, and for the most part it's the same thing. But I just wanted to show that there's, two different types of neck board here. Actually, there's three. The 7-pin. These are 9-pin, and the 7-pin is a totally different neck board. So there's no mistaking that when you see that neck board versus the 7-pin versus 9-pin. Anyway, so this is an example of a different style, but same type of neck board. So I'll put that over there now. For the fun part, I went ahead and just grabbed this spare one off of spare 7000 and plugged it in, and it fixed the problem. I had, as soon as I turned it on, it was way too bright, super bright. I got the raster lines, everything you'd expect for it to be when it's working properly. So I put this one back on and it was back to a very dark and dim image. So the only anomaly I could find was it had this resistor I showed before that was sitting here across like that. I took that out of the circuit. It did not make a difference. It had the original C204, this 250 volt 4.7 microfarad. It had the original cap in there, so I took this out, put this in there, because sometimes if it's the wrong cap or the cap is bad, the film cap is bad, it'll cause a dark image. That's why they include this cap in there, because this will cause brightness issues. So I put a replacement cap in there. It did not fix the problem. So I went through and tested all the resistors and components, and I couldn't find anything wrong. So that's when I grabbed this one that I knew worked and began doing comparative readings. So on this capacitor right here, let's see, it is C205. This capacitor right here, this film cap, if we read across that film cap, it is open in circuit. So that cap is right here, and it corresponds to these two pads right here. If we read across it in circuit on a working one, open. You see my leads are working, 0.1. If I touch these across here, open. If I go across here, same pads on this non-working one, open. But I've already replaced the cap with a donor cap off a donor neck board. Now, this is the original cap that was in there. If we go across this original cap, 1 megohm, and it's steady for the most part. So in circuit, I was reading 1 megohm across this capacitor on the bad one, but on the good one I was reading open. After taking out this capacitor and putting in a replacement, I now read open on this one as well, and this reads 1 megohm in circuit and out of circuit. So I'm absolutely positive that this C205 film cap is bad and was dragging down our G1 voltage. So actually, I'm sorry, G2 voltage. If we look at the trace here, let's look at this one. So our G2 pin right here is this pad, and it follows right to one leg of that C205 capacitor. This guy here, right there. So I think this capacitor was bad and dragging down our G2 voltage. So the only thing left to do is, now that I've replaced this, is let's put this back on the chassis, get the chassis back on the tube, and see if that in fact fixed the problem. So here we go. Alright, so we're all hooked up, ready to go. Everything is still turned way up like it was before when we had our problem. So if this works, when we turn this on, it should go super bright, raster lines, everything bleeding crazy, just like it was. Well, you didn't see it, but like when I had the working neck board on here, that's what it did. I didn't set anything back to what it should be. It's still all turned way up to get at least somewhat of an image. It's all still turned up the way it was with the neck board when it was bad. I'm assuming it's fixed now. So let's go ahead and turn this on. And if it is indeed working, I have not turned it on yet. We'll share in the knowledge if it is fixed. If it is working, it should be a super bright image here. So let's see. 1, 2, 3. Yes! Ha ha ha! Yes! Okay. Whoa, wait. Hey, black level. I think that's down. Let's, we'll just put this halfway. And then let's take our adjustment tool here and contrast all the way down. Brightness all the way down. Black level, I think that's, we'll just leave it at halfway. I don't think it makes that much difference on here. And there's our raster lines. Beautiful. Okay, let's turn our flyback down. Ah, nice. Okay, and we'll turn it up till we get our raster, and then turn it down till it just goes away right there in person. Then we will supplement again with contrast. Let's start with brightness. We turn brightness up until we get right there, and then supplement again with all good old contrast. Nice. There we go. Look at that. How about that? First time I ever seen that problem before. We had a bad C205 on the neck board. Crazy. Never seen that problem before. And there's all of our issues. I still don't know really what this resistor was doing. I've never seen that before. I don't think it's a factory mod, but as you can see, it doesn't really affect it. So I'm going to include this to send it back to the owner, and if he wants to reinstall it, if he needs to reinstall it, he can reinstall it. But we had a shorted HOT, a shorted voltage regulator. We had 3 polarized caps and the bipolar cap locations for the color. We had a bad C205 and a errant resistor that was installed that I don't think should have been. After all that, and of course we had a whole bunch of bad solder joints that we've already showcased. So after replacing those parts, fixing all the solder joints, reflowing, inspecting, and getting everything adjusted and looking good, we have a working monitor now. So very interesting. First time I've seen a bad C205 on the neck board. Let's make sure we've got vertical size adjustment. We do, but this is a secondary adjustment, so let's put that in the middle. Vertical position. Vertical position does in fact work. Horizontal position does in fact work. Let's do, let's readjust vertical size here. Yeah, see this tearing here? I wonder if we can fix that with a 50-60 Hertz adjustment. But that may be an issue of the test pattern generator, which is why I like to use an actual PCB when testing a lot of this stuff. Yeah, if I turn the 50-60 Hertz pot, that takes care of that, but it squishes the bottom. So if we unsquish the bottom right there, it tears the top. So let's disconnect the test pattern generator and hook up an actual PCB. And hang on, I gotta plug it in here. Give me a moment. Okay. Good old Mortal Kombat. And yeah, it's squished again. So that's why I like to use an actual PCB. This test pattern generator is nice just to make sure the monitor is working. But it's always nice to have an actual PCB when possible. Let's skip past the ROM check here. And nice. Okay. Horizontal position needs to be roughly there. Vertical size is good. See, no tearing on the top. So yeah, it's the test pattern generator. You can't always... if you have issues with your image and you're using a TPG, throw a real board on there, because a lot of times you'll be chasing your tail trying to figure out why I have tearing and screen size adjustment issues when it's something to do with a TPG, low battery or incompatibility or what have you. So if at all possible, try and use a real PCB. Now, I am interested to see if we can fix the width, because it's the coil is all the way out. It's pretty much as far out as it's going to go. Now if I drive it down, it's only going to decrease the width. See? The width is decreasing. And that is the limit right there. It's all the way out. And we have a black bar on, oh sorry, let's zoom out. About an inch on this side and an inch on that side. So our brightness is too high and our colors are way off. Not worried about it. But I'm hesitant to change the C38 width cap because this may be set up for a tube with a different reading of yoke. I can't say. So I'm not going to mess with that. I'll let the owner know that if he needs to increase the width he's going to have to replace C38 with a lower rated. The lower the rating, the wider the image. The higher the rating, the narrower the image. So if you want to increase your horizontal size, you want to go down in rating. To decrease the size, you want to go up in rating. So I'm pretty sure that's correct. Anyway, so I'll let this run. I might do some more tweaking and testing just to see if I can get some better colors here. We'll turn the blue up slightly. That's better already. Green. Nice. Better already. So I'll let this run for a couple of hours. I'll let the owner know that it's now repaired. Just to make sure, I'll do my normal burning. But barring any unforeseen circumstance, like I always say, we'll call it repaired. And that's another reason to have an actual real PCB is if you're going to run your burn-in for an hour, 2, 3, 4, 5, 24 hours, you obviously don't want to run it off a test pattern generator. So, but that looks pretty darn good. There's no interference. We know all of our size adjustments are able to be adjusted. There's no issues. Absolutely no tearing. So that was completely result of the TPG here. And it looks fairly good. Yeah, I'll let the owner know what the problem was. And I'll let him know about the C38 width cap. But otherwise, I will consider this a repair. Just, I've never seen a bad C205 before. All right, well, we learn something every day. That's why I like doing these videos. So that way, if something like this comes around in the future, I have a reference, and so do you guys. So thanks for watching. Like, share, and subscribe. I appreciate it. And another one successfully repaired.